Okay, so let's talk about the law of sine. This is not a sine.
Well.
Well, okay, it is.
Well, okay.
There's that famous painting of not a pipe. Whatever. Forget it.
No, I agree. I love that painting.
Okay, what is the law of sines? Levi, since you knew the law of sines earlier, do you remember the thing I told you was not the law of cosines?
Yeah.
What is it?
It's like, I guess it doesn't really matter the arrangement of the ratio.
Okay, how about triangle, right?
Yeah, so then mark each side as A, B, and C.
Okay, so A, B, C, make sure you get the angles opposite them.
Yeah.
Okay, check.
Alright, now you do the, so side A over the sine of angle A.
Okay, so the side length of A over the sine of A
Equals
equals
side B over the sine of
side
angle
B over the sine of angle B equals
side C over the sine of angle C.
side C over sine of angle C.
Yeah.
Oops, I don't know why that one.
Yeah, it's okay.
Just one big.
I guess I should have just erased the middle, right?
Fair enough.
Looks like a parenthesis anyway. Okay, so this is one phrasing of the law of sines. What's another phrasing of the law of sines?
The inverse.
Say that again, but with the right word. Not inverse, but reciprocal. Yeah, flip the whole thing over. So another phrasing would be sine of A over side A is sine of B over side B is sine of C over side C. And in practice, you do not end up using all, like this
Yeah.
chain.
Yeah, you'll
What do you
have
end up using?
two of them. and then you
Any particular pair. You guys follow that?
Right.
So it should be noted also that sine of A over A is also equal to sine of C over C, right?
F equals B.
And same thing here.
B knows not.
Really, you should think about these as a triangle and not so much as a line.
Yeah.
Cool.
So you should write those triangle.
I should, but I'm not going to.
Is there even any way in which something equaling something else would not equal?
No, equals is transitive.
Yeah. Otherwise,
Meaning that if you have a chain of equalities, because what we mean by the symbol is this thing here is exactly that thing there, right? Like these are the same object. We could make a symbol that works a little bit like equality that isn't equality in the same way, that would have problems with transitivity. But it would be a little bit bizarre. Almost is one of those. Like 7/8 is almost 1, right?
Yeah.
Which is
And 1 is like almost 1.1.
But 7/8 isn't almost 1.1.
Yeah, but I would never really say 7/8 is almost 1.1.
Yeah. that's
And
right.
I could continue this, right? Like 1.1 is almost 1.15, which is basically 1.2.
Yeah, that's just.
And then you're basically at 5/4.
Which is like.
And 5/4 is pretty much
1 and a fourth.
1 3/8,
Yeah.
right?
Yeah, so 7/8 is almost 1 and 3/8.
Which is like basically 12/8, frankly.
All right.
Right?
Yeah.
Like almost is one of these things that's not transitive.
the 7/8 is
Basically 1.5. Yeah, but 7/8 is
Yeah.
basically 1.5.
So this is equality is what's called an equivalence relation, and almost equals is not an equivalence relation.
Someone tried to tell me that they saw something on YouTube that explained to them that like when you have like 1.9999999 for a really long time, it's actually equal to 2.
That's true.
So I can use.
Yeah, I'll explain it to you after I'm done with
Okay.
this. Okay, so
Yeah.
the use of this is in pairs, right? And just make sure you keep things across from each other.
Right. Not next to each other.
Yeah, don't do next to each other. This isn't regular trig land, right? You guys good with that?
What do you mean across from each other and not next to each other?
Make sure that your side here
Oh,
and the
yeah,
angle
yeah.
here are across from each other.
100%, yeah.
There's an opposite thing going on, right? Because it's a sine,
Yeah.
right? And the hypotenuse is a little bit fuzzy in this picture.
It's the longest side you could. Longest side.
You guys see that?
Mm-hmm.
So if you wanted to demonstrate that this was actually true, how would you do that? 2 seconds.
So the sine of A would be opposite of it. So you just.
Okay, how about this? is this a right triangle?
No,
No. What do you need to talk about trig functions like sines and cosines?
a right
Cut
triangle.
that
A
now.
right
So you
triangle.
make a right triangle. out of
So cut it. So if I cut this one here,
it. Yeah,
right? Right triangle here, right triangle there.
yeah. So now the sine of A,
If I talk about the sine of A, right?
right,
Sine of A is going to be
whatever that side is.
whatever this side is, so I'll call that h quick.
So it would be
So this would be h over
B.
b, right?
So now the sine of.
So h is b sine of A, right?
Yeah.
Okay, but that was on this side. On this side,
Mm-hmm.
sine of b is h over A.
So B is,
So h is also A sine b,
okay,
but h is still h.
right.
So divide both sides by b over A, and you'll get to this part.
Ah,
Actually, you'll get to that part, but whatever.
Yeah, if you accept the.
You guys pull that? Okay, check that.